Well, um, picked up some of this today. It's modelling clay, not the best. I think plasticine probably better, but this is what I could get hold of locally at a decent price. I think it was £3 for that whole block, and it's made in Germany, of course, or France, or Italy even. There you go. Get it right eventually. Well, Italian clay for an Italian engine. But anyway, it has done the trick, and I will now do the big reveal. Dun 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 dun. So, some clay on the outside of the exhaust valve pocket, comes nowhere near the head. And then we have the sides of the pocket, which I suspect might be in contact, nowhere near. Big fat blob on the top. Another one on the side of the inlet valve pocket. But look at this. Boom. Haven't got one there. Boom. Boom. So, there's not enough squish clearance. So, it is this part of the piston, this ring, which we call squish bend on a piston, that is coming into direct contact, as I did suspect when I blued it, because you can see all these little spots, and normally when you see spots on blue it means it's had some kind of contact or some dust has picked up on it or something like that. But that is well and truly flattened, and you can see it's on the outside section of the squish. Go out of here. You can see a section there that has been squished, and there. So I would reckon it'll be exactly the same on the front. So if you look at the head, you can see where it is. So it was like I was saying in the last video, the squish band on the head seems like a parallel face to the top of the barrel to there, and then it tapers off, and then so that distance there corresponds to this distance that's been squished. See how it's been pushed inwards? This whole clay has been flattened and pushed inwards, which is what squish is supposed to do, because this is a fluid clay. It's acting as a fluid, just like liquid or gas. It all comes under fluid laws. So it's all been pushed into the middle. Now, as soon as I saw that, I actually thought, well, have a look at that. I hadn't really noticed this before, but yeah, it's quite obvious. So what I need to do is relatively straightforward. I need to take a measurement of how far the squish is above the get my fingers in the right place, the squish is above the top of the barrel there. Take a measurement for that. Looks about a mil, just over a mil. Then take a measurement of the depth of this cut here, that register which forms the outside edge of the squish, and basically I worked out it was roughly about a mil, because that's what lifted the head off. So I think what I'm going to do next is actually set this up to take a compression ratio measurement. So seal up this piston at top dead center, although I can't. Yeah, I suppose I could do that. Yeah, with the piston topped out. Okay, yeah, I can take a measurement of the combustion chamber volume. So that will be this volume in here minus this volume sticking above the squish, and then I can roughly work out a static compression ratio from that, and going from there I can actually work out, if I was to get this surface here all milled down by, let's say, 1 millimeter, I can then work out what volume that is and what volume it would add to the clearance volume above the piston, and how that would affect the compression ratio. Because I'm guessing when I do a compression ratio on this, it's going to be something like, I'm going to have a stab at 13.5 to 1. It wasn't unknown for my father to run engines with a high compression ratio like that and use avgas or blue gas, but not in this instance, because you can't use avgas or blue gas in racing anymore at all. You basically have to use, super supreme pump gas, or you can buy race fuels, but they're very expensive. But when I'm running that race bike, I actually use a tetraethyl lead fuel additive, which bumps all the octane up. But anyway, I'm digressing. So I can then work out, if I take a millimeter off this, I can work out what the compression ratio is, and then I can have a look at it going further, because ideally you want a 1 millimeter squish bend. So you want a gap between this face on the top of the piston and this parallel face in the cylinder to be 1 millimeters. On a super race engine that you're going to rebuild every 200 hours or whatever, you could afford to go to maybe 0.75 mil, but you really need to leave about 1 millimeter squish clearance. And 1 millimeter squish clearance on a piston of this diameter works very, very well at getting those gases into the center. So that's kind of where I have to go from here, I think. But it's actually quite good news, because it means that I'm not going to be getting the file out and butchering these by hand. I'm going to be taking this to a machine shop, and I'm going to make an estimate of how much I need to take off here to achieve a millimeter squish clearance. I don't think I've got a valve to piston clearance issue, but I can't check until I can roll the piston over top dead center with the valves opening and closing in the correct timing. So that's a way off doing that yet. That's where we are. I think that's quite good news, actually. It means the modification is going to be pretty simple and straightforward. Nice.